The James Webb Telescope has essentially revealed the clearest picture of Proxima B in history, uncovering stunning insights into a perhaps livable exoplanet. It obliges us, as we set out on an excursion through space, to reveal the mysteries of Proxima B and find out whether it very well may be the next Earth. We ought to take off into the tremendous spread of space where a baffling planet exists in the habitable zone of its star Proxima Centauri. This planet isn't just any typical rock. It's remarkable. See, Proxima B is found a mere 42 light-years from us. This planet is covered in mysteries and marvels. Could it be another Earth with seas and life blossoming on its surface? Regardless, there's something else. Proxima Centauri B isn't alone in that frame of mind around the red dwarf star. It has a companion, Proxima Centauri C. And who can say what other secrets the star system holds? Maybe there's another companion that we have yet to discover. The secrets don't stop there. Proxima Centauri transmits roughly the same amount of energy from its star as Earth does from the Sun. Could this truly mean that there's water on its surface and perhaps, indeed, even life? As we investigate beyond our own solar system, we encounter a totally extraordinary universe of exoplanets. Planets that circle stars other than the Sun. With 200 billion stars in the universe, the potential opportunities for exoplanets are endless. Some exoplanets even wander freely, untethered to any star, like wandering travelers in space. Among them all, Proxima Centauri B stands out as a particularly striking and captivating planet, with a year that lasts just 112 Earth days and a distance from its star that is generally closer than Earth is to the Sun. Beyond doubt, one side of the planet is continually washed in sunlight while the opposite side remains in eternal darkness. Now, we should talk about Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigil Kentaurus, otherwise known as Alpha Centauri A and Alpha Centauri B, together. These stars form the closest star system to our solar system. The two stars, Rigil Kentaurus and Alpha Centauri B, form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation Centaurus and are the third brightest stars in our night sky, with a peak brightness of under 2.7. Proxima Centauri, also called Alpha Centauri C, is a red dwarf or M-star, found 21 light-years from the other two stars, about 4 times the distance between Earth and the Sun. It is the nearest star to us. Proxima, in fact, means nearest star in Latin, and it was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being our closest celestial neighbor, it isn't visible to the naked eye, having an apparent magnitude of 11.13, which is much fainter than the human eye's limit of 6.5. However, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. They may not produce a lot of energy, but the internal convection processes at their cores keep them shining for trillions of years. Generally, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one thing, it's a flare star, meaning it has frequent and intense eruptions. As a low-mass star, its habitable zone would be much closer to it than the Sun's, projected to be somewhere in the range of 0.23 to 54 cents. Yet it's not as habitable as it seems. Proxima B is bombarded by intense ultraviolet radiation from its star, generally stronger than the radiation we get from our Sun. That's right. It's so intense that even the lightest particles of hydrogen are stripped away, along with nitrogen and oxygen. However, that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may not have a stable atmosphere, which is essential for regulating temperature and maintaining a water-friendly surface. Without it, living organisms would be vulnerable to harsh space weather conditions, making life almost impossible. So while Proxima B might seem Earth-like on the surface, it is far from being able to support life. People remain somewhat skeptical, as there are many factors that render it uninhabitable. The mission to uncover the truth about Proxima B continues, with some people still holding hope. One tool that has caught the attention of astronomers is the James Webb Telescope. After years of anticipation, the telescope was finally launched in 2018 and will help us determine if there is life on Proxima B. However, as with everything in science, things are never quite as clear as they seem. Different adjustments were needed to ensure that the James Webb Telescope delivers accurate images. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light. It can capture images of this light on the planet's surface and search for patterns that could confirm the presence of water or an atmosphere. However, what if the planet has an atmosphere that isn't conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a thick atmosphere that is far denser than Earth's, and extreme temperatures that would make it impossible for life to exist. The journey to unravel the secrets of Proxima B isn't without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, space agencies are feeling the pressure to find ways to observe planets like Proxima B. A lot is at stake, but the rewards are even greater. The opportunity to explore the unknown and uncover the secrets of a distant planet that holds the promise of life is a pursuit worth chasing. If the exoplanet were livable, might we one day be able to visit? It's the nearest exoplanet to us, which makes it so thrilling, almost like exploring our own backyard. Even more enchanting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it an ideal target for our mission for life beyond Earth. With it being so close, it's a fantastic opportunity for interstellar missions. Consider exploring this Earth-like exoplanet. Even though we can't yet go there, it's certainly on the radar for future missions. As technology advances, it's one of the most exciting endeavors in the field of space exploration. However, it's no simple task. It would take 75,000 years for a spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, a plan has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system and Proxima alongside it. This technology utilizes solar pressure to keep the spacecraft on course, eliminating the issue of running out of fuel. And here's something even cooler. This cutting-edge technology could provide insights into the possibility of life on other planets like Proxima B. However, just like anything ambitious, there are limitations. For example, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B could be like Venus, with a thick, hot atmosphere that is inhospitable. Moreover, get this, the James Webb Telescope can detect such emissions if it reaches a brightness of only 5% of the daytime side. Now, 5% might not seem like much, but when dealing with a star that is generally dimmer than our own sun, it's quite significant. If Proxima B has advanced civilizations, they may use reflective orbital mirrors to direct sunlight from the daytime side to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being massive gas giants while others resemble our own Earth. But what do we know about them? One type of exoplanet that has caught the attention of space scientists is the gas giant. These planets are similar in composition to Jupiter and Saturn but are much larger. Some of these behemoths have been dubbed super-Jupiters, surpassing even the largest planet in our solar system. Yet that's not all. There are also hot Jupiters, gas giants that orbit very close to their host star, existing in a scorched environment with temperatures that could melt metal. Imagine seeing such a planet up close, with its raging storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which have sizes similar to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being hard to study from afar. And we must not forget the terrestrial exoplanets, which resemble our own Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super-Earths, which have masses over twice that of our planet but are lighter than Neptune. One of the most interesting exoplanets recently discovered is Proxima Centauri B, which orbits the star of the same name. This planet is classified as a super-Earth, with an estimated mass of 7 Earth masses. Although it is close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri B isn't alone. It has a companion, Proxima Centauri C, which is significantly farther from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more intriguing about Proxima C is that it appears to be an incredibly bright world, possibly due to the presence of a ring system. There's more to uncover in the Proxima Centauri system. In 2019, astronomers detected a change in the star's orbital speed, which could be the result of another planetary companion. If confirmed, this planet will be known as Proxima Centauri D and will be roughly the size of Mercury or Mars. Imagine a life where the night sky is filled with stars and countless other planets, each with its own unique configuration and orbit. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made every day, it's an exciting time to be an astronomer. While we don't yet have an accurate count of exoplanets, we do know they exist, just as we know the stars that illuminate the universe. However, exoplanets are not without their challenges. They are often obscured by the glare of their host stars, making them difficult to study. Nonetheless, with advancements in technology, direct imaging of exoplanets is now possible. For an exoplanet to be directly imaged, it must be large enough to be seen by the telescope, far enough from its host star to avoid being obscured, and young enough to be hot and detectable from Earth. These requirements limit the number of exoplanets that can be directly imaged, but they offer a fascinating glimpse into the characteristics and composition of these distant worlds. Exoplanets are most commonly found through the changes they induce in their host stars. The gravitational influence of an exoplanet can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided significant data about exoplanets, including their size, distance, and temperature. Here are a couple of fun facts. Did you know that more than 22% of stars, like the Sun, have Earth-sized planets in their habitable zones? Or that TRAPPIST-1 is home to 7 rocky exoplanets with water on their surfaces? Exoplanets like those in our solar system can also have natural satellites known as exomoons. With over 4,000 exoplanets discovered so far, we know they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, but countless other exoplanets remain to be discovered. NASA's James Webb Telescope is revealing the secrets of the universe, one discovery at a time. This remarkable telescope has been gathering data and capturing stunning images of the universe, uncovering previously unknown wonders. Recently, it made history with a significant discovery that will change our understanding of the universe forever. NASA reported that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides crucial information about the planet's composition and evolution, offering us a glimpse into the secrets of the universe. This gas giant planet orbits a sun-like star 700 light-years away, and this finding marks a major breakthrough as we search for extraterrestrial life. NASA Chief Bill Nelson stated that this discovery would provide us with a new perspective on the universe that we've never seen, igniting excitement among astronomers and researchers worldwide. But that's not all. The James Webb Space Telescope has been busy capturing stunning images and organizing data about the universe in the infrared. The light from the young, outflowing object named 110 Iris-4 illuminates the cool, wispy cloud material, and the orange spots behind the cloud reveal light from distant stars, obscured by the ice in the cloud. This groundbreaking research was part of Webb's Ice Age project, which aims to study the evolution of ice from its formation to the development of icy comets. And that's not all. The James Webb Space Telescope has imaged the inner workings of a dusty disk surrounding a nearby red dwarf star, capturing it for the first time at these light frequencies in the infrared. This discovery provides essential insights into the formation of planetary systems and could help us understand how our own solar system was formed.